Following Hurricane Katrina, the U.S. Army Corps of Engineers constructed the West Closure Complex across the Gulf Intracoastal Waterway to provide flood risk reduction and storm surge defense for suburban New Orleans. A pump station, the largest of its type worldwide, is an integral part of this closure complex. When a pending storm necessitates closing of the pump station's sector gate, the drainage tributary to the Algiers and Harvey canals would cause substantial flooding, if not for this pump station. The area is home to nearly 250,000 residents, as well as businesses and industries, many of which are critical to national defense. So in the event of a hurricane, a team reports to the pump station to prepare for the hurricane, and up to 10 people will remain there during the storm event. Then, local navigation is notified, and sector gates and sluice gates are closed. Upon closure of the gates, the climber screen trash rakes are initiated, and the engines and pumping systems would be checked out and started.
The West Closure Complex protects about 100 square miles of suburban New Orleans, which is subjected to hurricane storm surges. The West Closure Complex pump station is the largest of its type in the world. It's the largest interior drainage pump station. It's the first line of defense. This is 9 times bigger than the normal pump station doing what it does, which is evacuate rainwater from areas that are low and essentially, in this case, below sea level.
No other pump station is of this size and has the capabilities of this one.
What we have here is unique because we have so many aspects of the mission that the Corps of Engineers is normally involved in.
During the cost summit, we had to make changes to bring the cost in line for the overall program. Arcadis was able to come in with HNTB and work as a team to implement these changes quickly.
The foundation is probably the mother of the structure. Because of this huge nature, the loads are mainly vertical, so instead of battering those piles, we kind of use the vertical piles. If you do vertical pile, that's going to save time in terms of driving of those piles, and also that's the most effective solution for this kind of problem.
There was a close coordination with our structural teams between the Corps and Arcadis and HNTB to get this work done. We were responsible for the design of the pump station and all the features associated with that. Those features included the access bridge, the site utilities, and the fuel farm. The access bridge serves 2 purposes for this project. One, it allows access to the pump station prior to and after a hurricane event.
It's imperative that we have an access bridge into the erection bay, which can take both the total pumping unit in and also bring one out.
The second purpose of it is to bring fuel into the pump station. You'll see supports on the side of that. It's a way for electric power to come in.
The bridge is a big protective structure, so we can hang these utilities off the bridge and underneath the bridge and feel safe that they're not going to be damaged by wind-blown debris primarily.
These are massive, massive engines that we have inside the pump station. And what happens is the water comes at the bottom of the pump station, gets sucked up by the engine, and then basically just discharges over the side of the pump station.
This type of pump, it's an axial flow pump. It has been around for a long time. However, it hasn't been produced on this scale before. There's the pump itself, the propeller that actually moves the water. That's connected to a shaft, which is connected to a speed reducer. There's a right angle gear that bends that shaft and connects to the engine. The engines themselves are about 5,500 horsepower diesel engines, very much like a railroad engine. The pumps can actually pump 1,740 CFS, cubic feet per second, and they pump over 8 million gallons a minute. Combined 11 pumps in the station.
There's so much water coming out of these pumps, you can fill an Olympic-sized pool in 4 seconds. Each pump that's out on this site has a localized control panel that you can go out to the pump, out to each individual unit and start it and stop it from there. However, in a storm event, we also have a control room in the safe house. They can visually see from there. There's cameras in throughout the pump station, so operators don't have to leave there, but they can operate this pump station from there. The safe house is a structure that will house up to 10 people during a hurricane event. We had to design around 72 hours of operation, meaning that once a hurricane or the commander of this area issued a warning, the gates would shut. The pump station then was required to pump flow out of behind the canals to the other side. So we had to have fuel for 72 hours on site, so it's self-contained. When that alarm is issued, that safe house not only had to withstand the 160-mile-an-hour winds, but also had to withstand the impacts if that building were to collapse around it.
The station itself is designed to operate unsupplied with additional fuel for 3 successive hurricanes. There's a number of systems that are critical to the operation of the pumping units. We have an air intake system that supplies, 13,000 cubic feet per minute to each of the engines. The exhaust system has to exhaust 26,000, about twice the amount of exhaust gas as the air supplied. There's lubrication and oil systems that are critical to, again, supporting the engine and the pumps. Engine cooling is a huge issue with the diesel engine drive, and much of the coolant or the engine cooling goes out to keel coolers, which are located in the discharge flume. So you have the water that you're pumping actually cooling the radiator, if you will, rather than air. The engines are anticipated to operate for anywhere from 6 hours per year up to about 80 hours per year.
We still have power as the main supply during normal operations, and if need be, we can, in a storm event, shut down the power breakers and operate just off of generators.
And we have 2 standby generators for each half of the pump station. We only need 1 each, so we're doubly redundant and can always have enough power to supply the auxiliary, which support the pumping units.
The climber screens or the trash racks that are there, the largest that have ever been built.
Basically, it's vertical bars, 4 inches on center, that prevent debris from getting sucked in and pumped through the pumps and possibly damaging them. The sluice gates are designed for more normal operating conditions when the pump station isn't running. Sluice gates provide a little bit of additional capacity, which results in lower velocities through the sector gate, which results in safer navigation.
This design had to accommodate maintaining that canal during construction.
It was very important to the navigation industry and the Corps of Engineers to have that freedom to navigate at all times.
We went up and down our division to pull resources from other districts that helped us. That also included some of the AE community, including Arcadis, that were pulled into this job to help design these projects as well as be involved in the construction.
This project had to have the pumps operational by June 1, 2011. In order to do that, the Corps proceeded with the ECI method of alternative project delivery to facilitate the construction and the design to occur simultaneously.
Because the project was under such a schedule constraint, the conventional design bid build process used by the Corps of Engineers wouldn't get it done within the required time frame. We solicited advice from the contractor sometimes for his methods of construction and how he'd build the project, what materials he might feel more comfortable using, and then we tried to design around that to aid him in doing the construction rapidly.
Normally, you would take 2 to 3 to 4 to 5 years for the design of this size. We did the design in less than a year. The client saw the value of getting this team together.
To get it done in the amount of time that we got it done, less than 2 years to do the overall construction of projects of this type of magnitude, is really amazing. I always take these type of projects very personal. There was not a member of my family that was not affected by the floodwaters associated with Hurricane Katrina.
If that structure was not there, we would be in a disastrous situation.
From an engineering standpoint, this is what we consider once-in-a-lifetime type of project. I think everybody worked hard. I think it's an accomplishment. It all came together very well. We don't get these opportunities very much.
Certainly, any time you get a chance to design one of the biggest in the world of anything, it's a very rewarding experience.
Arcadis, HNTB, and our other joint ventures and the contractor really played like a unique team on this job.
All these groups came together for the benefit of the people who live in this area.
The whole team did a terrific job.
So I take everything we do here very seriously because I know we're making a difference. What we do here will reduce the risk for the people in this particular region.